Dear friends, welcome back to Computer Guru VK Jain की computer classes. In this, all students of computer science and computer science and engineering, MCA, BCA, etc. In this particular module, I am going to discuss edge computing services as compared to cloud and fog computing services. Friends, this chart shows a complete detail of edge computing architecture. Edge computing processes data near the source of generation, that is your device, instead of sending everything to cloud. Now, in edge computing, first one is data sources. Edge devices, maybe camera, maybe IoT sensor, maybe industrial machines, mobile devices, and vehicles. And edge layer that processes data locally. First one is edge gateway and server that is used in data filtering, real-time processing, analytical or AI inferences, data catching, local data. And from here, it sends data only, and in turn, it gets cloud management and update. Now, cloud layer, this edge layer sends important data only to cloud, centralized cloud, and in cloud, you have facility of deep analytics, long-term storage, machine learning training, global management that takes you to user applications. It may be dashboard, mobile application, alert and notification, and end users. Now, how edge computing work is shown here. Devices generate data, edge server processes data locally. Then important data is sent to cloud if necessary. And from there, the cloud stores, analyzes and manages data, and it generates insights and results sent to users. The common application of edge computing is smart cities, healthcare, industrial IoT, retail, autonomous vehicle. Dear friends, now something on its working. Devices like IoT sensors, mobile cameras generate data, then nearby edge server gateway processes the data, then only important data is sent to cloud and cloud perform deeper analysis and storage. Key features of edge computing: low latency, that is faster response, real-time processing. Second, key feature is reduced bandwidth, less data sent to cloud, improved reliability, works even with weak internet, enhanced privacy, data processed locally, real-time decision making. Dear friends, edge computing services are major cloud providers offer edge services. First one is edge infrastructure, local server, gateway, micro data centers. Example, Amazon Web Service, Outpost, Edge AI, machine learning, run AI model locally. Example, Google Cloud Platform Edge TPU. Content delivery, that is in brackets CDN, faster content delivery near users. Example, Cloud Player. IoT services manage and process IoT devices data. Example, Microsoft Azure IoT Edge security services, local threat detection and data protection. Friends, we are comparing edge versus cloud differences. The feature is processing. In cloud computing, it is centralized data centers. Edge computing, near device. Latency higher, edge computing very low. Speed depends on internet, edge computing very fast. Data transfer in case of cloud computing large, edge computing reduced. Friends, here we are comparing several features of cloud computing, edge computing and fog computing. Location of processing in case of cloud computing, central data centers in edge at near devices. In fog computing, it is between edge and cloud. Latency, that is detail delay, cloud computing high, edge computing very low. In case of fog computing, it is low. The feature is speed. In case of cloud, it is moderate. In case of edge, it is very fast. And fog computing, it is fast. Data processing. In case of cloud computing, it is bulk processing. In case of edge, real-time processing. In case of fog computing, it is near real-time. Bandwidth use. In case of cloud computing, high, edge computing, low, and fog computing, it is moderate. Internet dependency. Cloud is fully dependent on internet. Edge computing is less dependent. Fog computing is partially dependent. Scalability very high in case of cloud computing, limited in case of edge computing, medium on fog computing. Security concerns. In case of cloud, it is centralized control. In case of edge, more local control. In case of fog computing, it is distributed control. Complexity. Cloud, low, simple architecture. Edge, medium, and in case of fog, it is high multi-layer. Friends, now something on core components of edge architecture. There are several components that must come together to build a scalable edge architecture. Let's take a closer look. Core component of edge architecture are edge device sends raw data to edge gateway where it is filtered data sent to edge servers, and edge server selected data is sent to cloud or data center. Now, what each component means. Edge device. The first piece is the actual edge device, such as an IO Internet of Things device, camera or sensor. This is where the raw data is generated and is the first point of contact in the system. Only minimum processing like data filtering is performed here. Edge gateway, this one. These are where data from multiple devices is aggregated. Basic analytics and pre-processing such as aggregation and format conversion also take place here. This one. Edge servers. Local processing for real-time application happens here along with running centralized workloads or AI inference models. This is where critical data is temporarily held before being synchronized to cloud. Network layer. Using LAN, 5G, Wi-Fi or satellite, this is where edge components are connected to each other and the cloud or data center provides long-term storage, in-depth analytics, and model training along with satellite management and orchestration. Friends, this we have already discussed. Only I will like to discuss fog computing that sits between the cloud and the edge, acting as an intermediary layer. Fog nodes are typically local area network based infrastructure like routers, gateways, or switches that provide additional processing closer to edge but with but with more capability than edge devices. Fog computing is used for coordinating multiple edge nodes, aggregating data, or or performing preform- pre-processing before forwarding to the cloud. Now, something on edge computing use cases. As as edge computing gains popularity, more use cases emerge. They include autonomous vehicle. Self-driving vehicle can generate multiple terabyte of data every day. That data needs to be processed and analyzed in real time to make split second safety decisions. In this case, each vehicle is an edge device and requires robust compute and storage resources. In case of manufacturing, from safety on the production floor to identify subpar products on the assembly line, edge computing has a quickly driven hold on manufacturing environment. In case the use case oil and gas, removing oil rigs in the ocean rely on edge computing to alert workers of equipment malfunction before they become serious enough to threaten lives. In case of healthcare, many healthcare organizations are turning to edge computing to track and maintain hospital equipment such as wheelchairs, alert doctors to potential health issues through, through patient equipment such as CPAP machines and vital sign trackers and increasing safety in hospital location via surveillance devices and alerting systems. In case of retail, retailers benefit from edge computing by using it to track inventory, surveil storage warehouses, analyze customer behavior, and more. In case of edge computing use cases, in case of energy, edge computing can help energy companies manage power grid automation, monitor the condition of assets in very remote locations, and alert team to potential equipment malfunction. Friends, in 2026, edge and cloud computing have matured into a unified hybrid edge to cloud ecosystem where AI-driven decision-making occurs at the edge for real-time responsiveness, while centralized cloud infrastructure handles large-scale analytics, training, and long-term storage. Edge computing has shifted from an emerging trend to a mainstream strategic pillar, with 45% of IoT created data generated can be processed at network's periphery. Thanks for constantly and meaningfully watching this presentation. Thanks once again from Computer Guru, VK Jain, who has written more than 130 books on practically on every aspect of computer science and internet technology. Uh, I my first book, my first Indian book was written by me, and I keep on writing latest books.